For this question, this is a application of the quadratic function. It is a application of the general form to complete square format. Okay, so you already practiced how do you convert general form back to general form to complete square. So for this application, it's a bit of working backwards. So if you read the question, okay, we got two vertical pillars. So the two vertical pillars, in any case, if you couldn't see where is the vertical pillars, these two are the vertical pillars. So each of them is 12 meter tall. Okay. And then they are going to model a suspension bridge using a quadratic function. So in any case, if you didn't know which part are they talking about, which part is the suspension bridge. So this is the bridge. So this part is going to be the bridge. And the x-axis is the horizontal distance from the left pillar, and the y is the height of the cable. So basically there's the x and y axis, which is here. So this is like our axis. Okay, so that's our axis. So we are going to model this with a quadratic function. Okay, so for the quadratic graph, right, there is a symmetrical feature. So there is a symmetrical portion here. So there is a symmetrical portion, and the symmetrical it's a bit like your line of symmetry. So this part is actually the lowest point. So this part is actually the lowest point. Okay, so we are trying to use the lowest point to make use of the complete square function, and then from the complete square we go back to the general form. Okay, so but we will try to answer the question first. So for the first part, we are supposed to answer the question where we wanted the vertical line that represents the pillar on the right. So the pillar on the right is this one. So it's supposed to be a vertical line. So being a vertical line, we know that the equation will be x equal to a number. So from here, you got to be counting how many sets of 3 meters. So you can count the sets of 3 meters. So you count the number of sets of 3 meters. So if you do that, you will have 8 sets of 3 meters. So the equation will be x equal to 24. So you cannot just put a 24 to match the vertical line has the equation of x equal to a number. So the equation that we're talking about is x equal to 24. Okay, then after that, we're supposed to find the quadratic function. So we make use of the lowest point to do a complete square. And then from the complete square, we expand out to get the general format. Okay, so I will need the lowest point. So after doing this part, right, you will be able to observe that this is a 12. So that's the symmetrical effect. That means this is 12. And then because the height is 3, I know that this is going to be 12, 3. So in this case, my minimum point is 12, 3. And then right, I also got a y-intercept. So if you observe carefully, this part is 8 units, 8 meters. So the y-intercept will be 0, 8. So with these 2 points, I can use these 2 points in a complete square format. So the method will be like this. So from here, we know that the minimum point is 12, 3. So I'll translate back to my complete square. So if I translate back to my complete square, then I should expect the function to look like this. So remember, this is the minimum value, the lowest value. And then from here, when you do a x minus 12 equal to 0, you get a 12. So that will be the format. But if I do this format, I will have an unknown a. So I'm going to use the y-intercept to find the unknown. So I'm going to use this to find the unknown. That means x is equal to 0, y is equal to 8. So if I do that, I'll be getting 8 equal to this. And slowly I will expand out. So eventually I will get my values of a. So once I get my value of a, I return it to the complete square. So after I return to the complete square, I can do out my usual expansion. The expansion that we learn, we can do out the expansion. So you gotta slowly work out your expansion to eventually get your A, B, and C. So this part is the basic expansion. So we make use of our complete square to work backwards to get our general format. So it's a bit opposite of your example one that you have practiced. In example one, you practice changing general format to complete square. So right now it's more like an opposite idea. So we use the opposite idea to apply to such stories.